So what is the difference between the classical physics and quantum physics? The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity, and then we have Maxwell's equations for electromagnetics, and that's all classical, and that works beautifully. However, when we get down to a small scale, when we get down to, say, the level of atoms, and the actual threshold or cutoff is unclear. It can be actually larger in some cases. A different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because in the quantum world, everything is in superposition of multiple possibilities, and in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place. This collapse, by the way, is utilized in quantum computation. Classical computers, for example, have bits where information is represented in a binary fashion as either 1 or 0. In a quantum computer, superposition is utilized, and information can be represented in superposition of both 1 and 0 at the same time. These are called quantum bits or qubits. So if you have a system of qubits in superposition, they communicate with each other non-locally. They don't even have to be next to each other. Non-locally, as long as they're isolated in one system. And while they communicate, they process information according to the Schrödinger equation very efficiently. And this goes on for a while and performs computation, and ultimately the system collapses, and each qubit of 1 and 0 chooses either 1 or 0, and that is the output or the result of the quantum computation.